Okay, so shall we start now? Yes, we are going to start today's lecture with a topic vector norms. Okay, so all students note down the definition what the vector norm is exactly. Vector norm, you might have heard the term today, but you are aware about vector norms in the form of a vector magnitude. Okay, so in the last lecture, we have defined a vector. We have defined a vector. Okay, so like this one, I this array. Okay, A equals to array 1, 2, and 3. So in last lecture, we have defined what a vector is in terms of a linear algebra and how we define the vector by using a Python. Okay? So one-dimensional array defined in a Python is itself a vector column. Now, magnitude of this vector is going to define a norm, right? So I'm again repeating this. Okay, vector magnitude is actually nothing but a vector norm. Okay, and there are multiple norms of a vector. When a vector is like say if you have n elements in a vector, okay, element 1, element 2, and element 3, and so on up to n. Right now, you can observe over here, vector A it has 3 elements, right? When you compute the length of a vector or when you define a magnitude of a vector, that can be defined over different concepts. Okay? What does it actually mean is defining a vector space, right? So, for this lecture, you may find it difficult to understand it because in terms of a vector norm, when you are defining a vector norm in terms of a different spaces, then in that case, mathematical calculations are required to be done to understand how it actually going to work, right? So, however, in today's lecture, as there are functions already defined in the Python library, and only those functions we are going to directly apply to calculate various norms. And hence, to understand the concepts very clearly, we are going to solve it by using pen and paper, right? And when you solve it by using pen and paper, then you can actually understand how Python compiler is calculating the different types of the vector norm, right? So what I can do now is I'll share with you a screen which defines the vector norm. You all students take pen and paper and note down the definition of different types of the vector norms. And then when we will go through the examples, I'll ask you to calculate by applying those mathematical formulas. And after that, we will execute those norms by using Python instructions. And then we will see whether our answer is correct or not, or whether the Python is returning the same value or not, right? So I'll share the screen with you all. Okay. So this is visible to all of you now, right? Now listen here. This is, we can calculate n types of the norms for the vector. Okay. So we can have a L1 norm, we have a L2 norm, up to so on, we have a Ln norm. Now have a patience and understand how the norm is defined, right, over the space of a vector. So space of a vector is nothing but the total elements vector contains. In earlier example, we have defined A is equals to a one-dimensional vector with value 1, 2, and 3. So that vector was having 3 values, that is 1, or we can say 3 elements, E1 that is value 1, E2 that is value 2, and E3 that is value 3. So what is actually been defined over here, you can observe in L1 norm. What L1 norm says that it is applied to individually every element of a vector, and it is represented like this. Okay. How we are going to represent a L1 norm in a mathematical terms is, this is a notation for a norm, and suffix this one indicates that this is a L1 norm, right? Similarly, L2 norm defined by using this double vertical lines, and the suffix 2 indicates it's a L2 norm. Up to so on, we can have Ln norms. So Ln norm is defined again, the two vertical lines applied on every element of a vector and suffix n, which indicates that it's a Ln norm, right? So in case of a L1 norm, how we are going to compute it, right? So you can consider each and every individual element. Okay? So say this vector has e number of elements, okay, n number of elements. E is specifically defining a individual element of a vector, so collection of elements. So this value of I will run from 1 to n. Okay, 1 to n, it means that from element 1 of a vector, then element 2 of a vector, element 3, up to so on, the last element of a vector, right? So what we are going to do is, we are applying summation operator. It means we are going to perform an addition, okay, over what? Over each and every element of a vector. And in case of a L1 norm, each element of a vector is being powered with 1. Okay? I'll repeat it. You can understand it very easily, that what we are going to do is, we are taking an individual element, that is E1, element number 1, plus to the power 1. Okay, plus E2 plus to the power 1, plus E3 plus to the power 1, and so on up to the last element. And this is what the L1 norm is. Similarly, we will have L2 norms, right? How L2 norm is defined? E1, that is element 1 raised to the power 2, because it's a second norm. Okay, this is a standard definition of a norms, and it has been defined like this. And how we are calculating it? To understand this formula, you have to assume that E is an element of a vector, and I will run from 1 to n. So E of 1, that means element 1 of a vector raised to the power 2. Okay, plus element 2 of a vector raised to the power 2, plus element 3 of a vector raised to the power 2, up to so on, nth element of a vector raised to the power 2. After performing an addition, whatever value comes of this sum, it will be taken square root of it. Okay, raised to the power 1 by 2, under root of. Okay, so under root of this, right? So here we will also have the same term, that is 1 upon the nth norm. So 1 upon the norm was the 1, and hence 1 upon 1, it returns 1. Here we are calculating second norm, and hence this entire term raised to the power 1 by the norm, that means 1 by 2, right? Similarly, when we are calculating the nth norm, what we have to do is, individual element L1 raised to the power n, that is element 1 raised to the power 1, element 1 second raised to the power n, up to so on, nth element, okay, the last element raised to the power n. And this entire sum term has been taken raised to the power 1 by n, that is nth root. Okay, so 1 upon raised to the power 1 by n, right? So now consider here, if I ask you to calculate the L3 norm, if I ask you to calculate L3 norm, how L3 norm will be defined in that case? L3 norm will be defined as I equals to 1 to n, e of I raised to the power what? 3. This n will be replaced by the nth norm. That is, if L3 is calculating, then it is raised to the power 3. So, first element is to the power 3, second element is to the power 3, plus third element is to the power 3, and so on up to the last element. And this entire sum term is being used to the power what? 1 upon 3. Right? Similarly, how you define L4 now? L4 norm will be element 1 raised to the power 4, element 2 raised to the power 4, up to so on, all the term summation is raised to the power 1 upon 4. Okay? I hope it is clear to you how we are calculating or how we are applying the norm, vector norm formula on the given vector. So what you all can do is note down these three formulas, and this is generalized. The last one is a generalized formula to calculate any nth norm. Okay? When you want to calculate L1 norm, you can replace n by 1. When you want to calculate L5 norm, you want to replace n by 5. Okay? So you note down this formula, and then we will go to see some examples on the norms. The value of I. Okay, there is a question on value of I. The value of I will always run from 1 to n. That means E of I. E of I represent the individual element of a vector. E equals to I equals to 1. That means E of 1, first element of a vector. E of 2, second element of a vector. E of 3, third element of a vector. Up to so on, up to the last element of a vector. Okay. So E suffix I indicates that it is the ith element of a vector. And I will be going to give the value 1 to the last element of a vector. Okay. So I hope it is done. You all have noted these formulas, and then we will go to our Colab file. So now observe here, this is my vector. Okay. This is the vector defined. So according to vector, what is the value of E suffix 1? What is the value of E suffix 1? Element 1 is having value 1 according to this vector. Okay, this is a vector. A is my vector. How many elements does A have? A have element 1, element 2, element 3. Okay. So element 1 is having vector 1, right? Then element 2. Second element is what? Having value 2. Then third element is having value 3. Now, according to L1 norm, what is the definition of L1 norm? It says that we need to do summation of these terms. That means E1, E1 to the power 1. Okay. Plus E2, element 2. Element 2 to the power 1. Plus element 3 to the power 1. Okay. This sum is being completed. Okay. Summation term is completed. Summation term raised to the power what? Now 1 divided by 1. Okay. Summation raised to the power 1 divided by 1. That means it is 1 divided by 1 means you will get 1 over it. And raised to the power 1 is nothing but a term itself. So you calculate manually and you have the value L1 equals to E1. What is the value of E1? The value of E1 is 1. So 1 raised to the power 1 plus E2. The second term. What is the value of E2? E2 is value having 2. That means 2 raised to the power. raised to the power 1 plus element E3 raised to the power 1. Okay, and E3 is having value. So what we have here is 3 raised to the power 1. Okay. So we have completed that summation of E1 raised to the power 1, E2 raised to the power 1 up to last element. Last element of our vector is 3. So up to E3 raised to the power 1. And this is being covered with 1. Okay. So what you will have here as L1 equals to, what is the value of 1 raised to the power 1 is 1. Okay. Plus, what is the value of 2 raised to the power 1 is 2. Plus, what is the value of 3 raised to the power 1 is 3. Okay. And raised to the power 1. So perform the summation. Sum of this 2 plus 2, 5 plus 1, 6. Okay. So it is 6 raised to the power 1 is equals to 6. Right. So this is what the L1 norm is. Okay. Now, if we want to calculate the L2 norm, so this is for L1 norm. We want to compute L2 norm of the same vector. If we want to apply L2 norm on this vector, then what will be the values? How we will define this? We'll reframe this particular term as L2 norm. What happened in L2 norm? E1 raised to the power 2, E2 raised to the power 2, and E3 raised to the power 2. This raised to the power 1 divided by 2. Okay. So if you calculate it and if you apply it to the vector, it will have the values as E1, that is my element number 1 is 1. So it is 1 to the power 2 plus element number 2 to the power 2 plus E3, element number 3, okay, is to the power 2. So 3 is to the power 2. Okay. And this whole term of sum is to the power 1 by 2. Right? So this way, how you will get the L2 norm. And similarly, when you calculate norm number L3, this will be square. Instead of square, this will be the power of 3. Element 1 raised to the power 3, 2 raised to the power 3, element 3 raised to the power 3, and this all summation term will be powered by using 1 upon n. And it is, if n equals to 3, then it will be 1 upon 3. Okay? And this is how you will be going to calculate this vector. So we will apply over here in case of Python. We have defined a vector A and we calculate the norm. So I say for the L1 norm, I have taken the variable L1. L1 represents here a variable to calculate L norm. So there is a function called as a norm. So this norm function, it will take two values. Okay? Function norm will take two arguments. Argument number is a vector for which you have to calculate the norm. Okay? Your parameter 1 for the norm will be a vector. And the second parameter is the value of n. Value of n is representing whether n equals to 1. If it is n equals to 1, then it represents it is a L1 norm. If value of n equals to 2, it represents it is a L2 norm, and so on. Execute this. So we have this print A, we have displayed the values of a vector, and we have this L1 norm calculated and displayed. So value of L2 is 6. So we can observe here, we calculated the value of X is 6, and hence we got it at 6. Okay. There is a question from Nidhi. Nidhi is asking, can we find L4 norm even if there are only 3 elements? I would like to tell all the students that when we are calculating the norms L1, L2, L3, L4, L5, up to so on, Ln, there is no restriction on how many number of elements a vector should have. Okay? So if we have a vector with element 2, a vector with element 3, or a vector with element 5, we can define any norms on this vector. So observe here, a vector was having 3 values. Still we have calculated the L1 norm. So there is no restriction on if you are calculating the L1 norm, the vector will have a 1 value. No, it is not like that. A vector can have any n number of values, and we can apply or we can calculate any kind of a norm or any type of a norm. L1 up to L of n. Okay. There is a question from Shreyas and Yash who are asking that what is a library defined for the norm. Okay. So I'd like to tell you for all the students who have been, we have defined here a library of line elements. Okay. So this library is used for uh, for for calling a function called as a norm. Okay. So norm function is defined under the NumPy library, which has the set of function defined under line angle. Okay. Right. So this has been defined by using a library. Right. So when we calculate it by using a norm function, or whenever you are using a function norm in the program or in your Python file, you have to first of all import this norm function. Okay. So when you are importing a norm function, you have to import it through this library class. So that is from numpy.lin. Okay. So this will be going to define a this is a library which contains this function norm. Right. So here we have only imported an array function here. Along with array function, we have imported a norm function. Right. So we will go ahead and we will see the next, that is the L2 norm. For L2 norm, we have to pass or define a function that is nor A. Okay. This is how a L2 norm is calculated. With elements 1, 2, and 3 that is defined. Then we have said print A 1, 2, 3, and then calculate norm L2 is equals to apply norm on A and print L2. So you got the value. So those who have calculated this value by using calculator, they can cross-check whether you are getting the same answer or not for this L2 norm. Okay, there are few questions from the student that I would like to tell before moving ahead. So I'll read the questions one by one and then I'll answer so that all will have a clarity amongst how we are calculating the norms. I hope it is visible to you all. I have taken few of the questions. All other questions were repeated and they were same. Okay, so one by one we will take the same questions. So question 1 was asking about like use A2 or just A1. Okay, and similarly the next question was there, that is in L1 norm we have said the function norm in bracket, that is a vector on which we have to apply norm, and then what which level of a norm we have to calculate, is it norm 1 or 2 or 3, right? And I told you the second value is the value of n. If n equals to 1, it says L1 value. But in case of a L2, we have not specified the value of n. And similarly, that goes to our this question. Okay, that is a norm. I'll have it on the same line. Okay. So which says that L2 norm, we have not defined the value of n, no value of n, and then still it is possible to get the desired output. Okay. So I'll write here the instruction which we have written for the L2 norm, which was L2 is equals to norm in bracket A. Okay. So I'd like to tell you what is the norm over here. In case of a Python, this norm is a function defined in a Python to calculate the norm. Okay. So all students will listen carefully and understand that what is the difference. In case of a Python, a norm is a function defined under the library LIN-ALG, okay, under the library of NumPy. NumPy.lin ALG. Okay. This LIN-ALG is for linear algebra. Okay. This LIN is linear algebra. In NumPy library is for numerical Python, which supports various numerical operations, and for advanced linear algebra, you have to specifically use linear algebra library. Under this library, we have this norm function defined. Now, when you define a function, in case of any programming language, I'll tell you the very important and a very good property of a programming language. It is not only for the Python, but this property applies to C programming, C++ programming, Java programming, R programming, Python programming. Okay? All types of the programming languages, they have this property. This property is called as a constant parameter. In that case, it is used to avoid a normal error done by a programmer. Okay. For example, in this case, what we expect is we expect that the programmer should provide two values to the norm function, or a programmer have to provide two parameters. Number one is a vector on which a norm is calculated, and the second parameter should be the value of n, that is which type of a norm we have to calculate. But to handle the normal errors, to handle the basic errors, the function can be defined by using the constant parameter. So when we define the functions, we can have some default values to the parameter. So this norm function have the second value as a default value, which is 2. I'll repeat once again. When the norm function is defined under this linear algebra file, okay, or under this linear algebra library, this norm function have second parameter with default value equals to 2. Okay, and hence any time when you apply a norm, when you calculate a norm and you don't specify the second parameter, then in that case it will by default take value of n equals to 2. And why it is taking only value equals to 2? Why the function norm takes only default value as 2? Because in case of a library linear algebra where the function norm is defined, they have defined this function norm with default parameter value for n equals to 2. So your n, that is the label of a norm, is defined by default equals to 2. And hence, if you specify any particular value like here, then the value of n will be assigned equals to 1. And in this case, if you don't specify a value, then in that case, by default, it will take 2. Okay. So if you calculate the L2 norm like this, or if you calculate L2 norm like this, is having the same meaning. Okay. And it will return you the same output. So I hope the answers to all these 3 types of the question is clear to you all. Okay. So whenever you calculate a norm of level 2, then in that case, if you don't specify the parameter, it is by default going to calculate the second norm for you. Okay. And if you specify it, again you will have the same value. Right. Now I can have this question actually who has asked, I have not noted here the name of a student who asked this question. Actually, in case of a Python notebook, when you calculated L1 norm, this L was small. All the students who have a note over here, we use small L. And hence it was L2 norm. But the student who was asking this question is using 12, not the L2. Here it's not a 1, it's a L. You have to replace this L here. And syntax error was can't assign to 12 because 12 was a number. We cannot assign a value to a number. You can assign a value to a variable. So in this case, your question or your compiler was giving you error because on the left hand side, the variable L2 was actually returned as a 12. Okay? And hence you got the error in this case. So you correct this instead of 12, if you use L2, then your problem will get solved. There is a one question asked by Vivek. This says L0 norm. Okay, L0 norm. So you can even calculate the L0 norm. Actually, it is not used much, but yes, you can calculate the L0 norm. Okay. So what will have a L0 norm? In case of a Python, it can be calculated as L0 is equals to norm a comma 0. Okay. And if you put it into the formula of your Ln norm, if you put n equals to 0 in the formula of L1 norm, Ln norm, what do we have? We have L0 is equals to, what do we have? Element 1 is to the power 0 plus element 2 is to the power 0. Okay. And up to so on element n. Element 3 is to the power 0. And this entire sum term is to the power 0. Okay. Then if you apply it to the vector A, that is 1, 3. How the value will come here? It will be L0 is equals to, what you will have? 1 is to the power 0 plus 2 is to the power 0. Okay. Plus 3 is to the power 0. And this complete sum is to the power 0. Right? Okay. So what you will have in L0 is equals to any number is to the power 0 is what? It's 1. Okay. So 1 plus, this will not be there. Sorry, this will not be there. This is 1 plus 1 plus 1. Okay. This is equals to 3. This is how you will get for L0. So this actually is the formula for L0. So you can note down separately the formula for L0. So we will go to our file. Now we can have here this. So we'll execute this and we'll calculate it by using different norms. So A, comma 2. Calculate the norm like this. We get the same out. Okay. Similarly, we calculate norm A, comma 0. That is L0 and print L0. We have 3. All of you, please note down the formula of L0 norm. I have defined. Okay. So this is the formula applied for L0 norm. Okay. Right? So you can have a different norms calculated. Then you can have a L3 norm by using n comma 3 and print L3. So L3 norm is calculated. You can have L4. Now just observe here what I am doing, what I am calculating, just observe here. So L3, after L3 I am calculating L4, comma 4 and print L4. Okay. Then after that I can calculate L5. Right? Now what you can do is you can just observe over here. Someone has asked me the question even for calculating the norms. So we are going to calculate the norm for defining a vector space. I already told you the application of a norm actually is the vector space calculation. And now how it has been defined and how it has been decided by using the vector norm, this question is going to be answered by the next topic. Okay? So just observe over here what values you are getting for the same kind of vector, right? When we have calculated the norm 0, it was having the value 3. Okay? When we calculated the norm L2, it was having value that is 3.74. We have applied the same value of, or we have applied the norm function to the same vector. Now, after L2, when we calculated L3, see, L2 was 3.74. L3 was 3.30. And then we calculated L4, which gave us the value 3.14. Then we calculated L5, which gave the value 3.0077. Okay. What I'm interested now, I want to know for a given vector, which level of a norm is the highest norm. Okay. And repeat the question. The question is for a given vector, which norm or which level of a norm is the highest norm, whether L1 is the highest, whether L2 is the highest, whether L3 is the highest, and so on, right? So we are going to define that. I have defined some more, I can say, the library function from NumPy and the maths. Okay, so I will inform this to all the students. Just note it down. When we study some more related function, or when we have a separate topic on that library function, then we will be going to explore that library completely. Okay? Right now, we will just concentrate on an individual function which we are going to use from the specific library, right? So you can observe here, to calculate the max norm, what I did it, I first of all imported the usual two function, that is array and norm. Along with that, sometimes I may require to define an infinite value. Okay? So for that, what I did is I have imported from the math library, that is INF. Function INF is been imported. After that, what we did is we have defined a vector with values 1, 2, 3, and I have displayed the value of a vector. Okay. So what this INF function actually going to do for me, it is going to define the values here, or it is going to supply the values over here starting from 0, 1, 2, 3, 4, 5, 6 up to what? Infinite. Okay. So I'll repeat over here the use of this particular term, okay, INF. I am going to apply or to calculate the norm. So this particular function, what is going to do, it is going to calculate A on some infinite term. And then on that infinite term, I'm calculating the norm of a vector A, and I'm assigning to a variable max norm. This will tell me the value of the maximum norm defined, or this will extract the maximum value defined or the max norm defined for the vector. Okay? So we will execute it and we display the value. And hence, if you observe from the earlier one, we will have this 3.0. Okay? 3.0 is the value for the max norm. Get it? Okay? So you will have to remember this function, and when you will use this particular functions in multiple examples, and through that example, we will explore this function more, right? So for this example, you just remember that how we are applying this INF to the maximum. Okay. So we will finish here the topic of a norm, and then we will recall this. All of you just have to note it down in your copy. Okay, I'm going to share this file even with you all. But all this small examples which we have seen, we actually require this particular things in the next coming topics. Okay, and then we will explore more on this and about its usage. Okay, so we'll go ahead.